A numberful Wednesday, students! Join me as we learn how to count, solve, and enjoy math. This is Teacher Jerelle and welcome to our class. Some of the objects you encounter in daily life are based on congruent triangles. For example, the design of a plier involves congruent triangles. These congruent triangles ensure that the jaws of the pliers remain parallel. For today's session, we will talk about triangle congruence. Are you ready, students? Come on, let's begin our numberful journey. Before we proceed to the lesson, I would like to invite you all to a magical learning experience at home with Vibal's Happy Homeschool program. You may enroll in a standalone program in math. Just check the link in the description box to learn more. As we learn about triangle congruence, we will answer these two questions. First, what is triangle congruence? Second, what are the postulates that prove the congruence of two triangles? Come on, let's proceed to our lesson. Do you still remember what triangles are? A triangle is defined to be a polygon with three sides. This means that all triangles have three sides and all polygons with three sides are triangles. Now, take a look at these two triangles. We can visualize how the two triangles may be cut and moved so that one triangle would perfectly coincide with the other. If so, then A would lie over D, B would lie over E, and C would lie over F. In this case, we can say that triangle ABC is congruent to triangle DEF. Let's learn about triangle congruence. The triangle congruence states that the correspondences A corresponds to D, B corresponds to E, and C corresponds to F are called congruences between triangle ABC and triangle DEF if each pair of corresponding sides is congruent and each pair of corresponding angles is congruent. Observe that the order of writing of the vertices must follow the indicated correspondences between vertices. A corresponds to D, B corresponds to E, and C corresponds to F. There are several correct notations for congruence between triangles ABC and DEF. However, we have to make sure that the notation reflects the proper correspondence between vertices. Thus, triangle ABC is congruent to triangle DEF may also be written as triangle BAC is congruent to triangle EDF but not as triangle BAC is congruent to triangle DEF. Take a look at these examples. Which of the following triangles appear to be congruent? The only two triangles that appear to coincide when laid directly on top of each other are triangles 1 and 3. The correspondences are A corresponds to H, B corresponds to I, and C corresponds to G. Thus, we may write triangle ABC is congruent to triangle HIG. Fantastic! Now, take a look at this. Which of the following triangles appear to be congruent? The only two triangles that appear to coincide when laid directly on top of each other are triangles 2 and 3. The correspondences are E corresponds to G, D corresponds to H, and F corresponds to I. Thus, we may write triangle EDF is congruent to triangle GHI. Awesome! How about this? There is one pair of congruent triangles in the figure. Can you list down the 6 congruences of sides and angles of the triangles? Good job! From the figure, we have triangle AFD is congruent to triangle BCE. Then, AF is congruent to BC, AD is congruent to BE, FD is congruent to CE, angle A is congruent to angle B, angle F is congruent to angle C, and angle ABF is congruent to angle BEC. You did great, students! But wait, there's more. If we can list 6 congruences of sides and angles, then the triangles involved are congruent. In what instances can we guarantee that 2 triangles are congruent if we do not have all information about its parts? Now, let's do this activity. Use a ruler and a protractor to draw a triangle with side lengths 3 cm and 4 cm and for which the included angle between these two sides is 40 degrees. Can different kinds of triangles be formed satisfying these conditions? Let's see. First, let's create a 40-degree angle using a ruler and protractor. Now, mark off segments measuring 3 cm and 4 cm respectively along each ray starting from the vertex of the angle. Connect the endpoints of the two segments to form a triangle. If we try to draw another triangle that satisfies the given conditions, we would end up producing a triangle congruent to the one earlier. This result is a specific illustration of the Sas Congruence Postulate. The Sas Congruence Postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Now, let's say we have a triangle with angles 40 degrees and 70 degrees and for which the included side is 4 centimeters. Can different kinds of triangles be formed satisfying these conditions? Let's see. First, draw segment AB measuring 4 centimeters. On each endpoint, draw rays to produce angles measuring 40 degrees and 70 degrees respectively. Mark the intersection of two rays as C to produce triangle ABC that satisfies the given conditions. If we try to draw another triangle that satisfies the given conditions, we would end up producing a triangle congruent to the one earlier. This result is a specific illustration of the Asa Congruence Postulate. The Asa Congruence Postulate states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Now, how about this? Let's say we have a triangle with sides measuring 3 centimeters, 2 centimeters, and 1.5 centimeters. Can different kinds of triangles be formed satisfying these conditions? Let's find out. Draw segment AB measuring 3 centimeters. Now, use a compass to draw a circle with radius 2 centimeters centered at A and another circle with radius 1.5 centimeters centered at B. Next, let C be one of the intersection points of the two circles. Then, triangle ABC satisfies the given conditions. As mentioned earlier, every triangle that satisfies the said conditions will be congruent to the triangle shown. This is a specific illustration of the Sss Congruence Postulate. The Sss Congruence Postulate states that If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. The SAS, ASA, and SSS congruence postulates show us that we only need three congruences to prove that the two triangles are congruent. Now, can you identify which postulate SAS, ASA, or SSS can be used to prove that the following triangles are congruent? Let's start. Take a look at this. Since three sides in triangle ABC are congruent to three sides of triangle ADC, then the SSS congruence postulate applies. How about this? In these triangles, you can see that there are two matching angles and a matching side. Angle Y is congruent to angle D, XY is congruent to AD, and angle X is congruent to angle E. Thus, the ASA congruence postulate applies. That was fantastic, students! Now, let's go back to our two questions earlier. The triangle congruence states that the correspondences A corresponds to D, B corresponds to E, and C corresponds to F are called congruences between triangle ABC and triangle DEF if each pair of corresponding sides is congruent and each pair of corresponding angles is congruent. The SAS congruence postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. The ASA congruence postulate states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. The SSS congruence postulate states that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. You did great! I hope you learned a lot about triangle congruences. If you did, click thumbs up and share this video to help students like you to count, solve, and enjoy math. Don't forget to click the subscribe button. Of course, to experience magical learning at home, check out Vibal's Happy Homeschool program. Just click the link in the description to learn more. Again, this is Teacher Jerelle and see you on our next Numberful Wednesday.